Well, I haven't made a video in a while, so I figured I would make a kind of brief overview of my new Siren. What you're looking at is a Federal Signal, or Federal Sign and Signal, I should say, Thunderbolt 1003A, late 1975 build. There's the tag for those who like to keep serial numbers, 3568-D on the serial number. And this was a 3-phase model, as denoted by the A at the end of the model number. I've actually since converted this to a single phase unit, and I'll get into that here in a second. But overall, this unit is in really good condition. This is actually all original paint. This thing was out in the desert in New Mexico, so the climate was really good to it. There is some wear and tear on it, but where the paint is still on the unit, it could almost be factory fresh. So you can kind of barely see where the old decals used to be as an intermediate Federal Sign and Signal logo. You can kind of see there where Civil Defense round logo used to be, and again there on the front. The text right there is the manufacturer of the metal Federal used for their cabinets and their housings. For those of you who are familiar with these sirens, you notice this unit has 4 RCM boxes, or 4 boxes on it. That is because I have changed something with this siren. Not everything is original, like I said. This right here is the RCM3, which controls the fire signal. Again, we'll get into that. This is the radio cabinet, obviously not original to the unit because it has that newer logo on it. And then over here on the other side, I have an RCM from a different Thunderbolt, and then the original RCM1 that came with this unit. So yeah, we'll kind of get into the components of this siren and how it works. All right, so looking at the siren as a unit, like I said, this is going to be kind of an overview of how this works for those of you who aren't really familiar. But basically, you have a fan with a stator around it, or in this case, you have a fan with a cap on it, and there is one hole there on the front, and it's up here, and this fan spins. And the faster it spins, the higher frequency of pulses that it makes as the blades cross in front of that stator. So the lower frequencies, when it's slower, as it speeds up, it makes a higher frequency. As it goes up and down, you get that wailing siren noise. So this is where the noise is made. It's forced out through here. These 2 boxes right here are actually valves, and they can actually make special signals for the siren, which I'll get into here in a minute. Comes through here through the horn, and then is forced out right there through this exponential horn. Now, this siren has a supercharger on it, which helps maintain the volume level, and that happens in this very, very large box down here. And what happens is, this is an air intake right here. Air is sucked in, it goes down through a roots blower connected to a large 10 horsepower electric motor, a big air pump. And what that does is provides very, very, very high volume, low pressure air. That air exits right here through this elbow, travels up this tube all the way to the top, and is pushed out in the front. Now, this lower part right here contains a drive system for that horn, and what that does is it's a motor connected via belt to a gear reducer, and it drives this horn around in a 360-degree circle. So everything above the screwdriver actually rotates around, and then, like I said, this is what drives that rotation, and then there's air. And the thinking with that is that they wanted to maintain the sound output, or the volume, at all frequencies. And this is important because as this is a fan, the slower it spins, the lower the pulses, the lower frequency, but also the lower the output of the siren. So if you're constantly forcing high volume air through that, it's going to make the whole thing loud and keep a consistent volume. Now, on the sides here, you have 4 control cabinets. This particular unit actually standard would come with two. You'd have a box which would control all of the motors. You have the motor in there, you have the motor in here which turns the siren, and then you have the fan motor up there. Now up there you have those two valves which can be operated either simultaneously or one at a time, and what that does is it can produce like a pulse signal or like a high-low signal like you'd hear on a fire engine or a police car in Europe. And this box right here houses the control for that. This is a radio box, which is how the siren would receive signals. You see there's an antenna right here. Again, we're going to get into all this and how they work and what they look like on the inside. And this over here is an extra box I put on because I want something to be able to store the wiring and cables when I want to plug this siren in. I actually, we have an EV charger, but that is a 60 amp service outlet, and then the associated electrical components with that. So yeah, I think what we'll do first is get into the actual motor control box, which is called the RCM1. If it's a single phase siren, it's an RCM1B. 3-phase sirens, RCM1A. This was an RCM1-3. However, because I do not have 3-phase power at my house, I ordered a new motor starter for this right here. This would be a 3-phase motor on a 3-phase unit. I've swapped out the 3-phase motor with a single-phase motor, so effectively this is all a single-phase unit now. All right, so this is what the motor control box looks like. Again, this is referred to as the RCM1, RCM1A if it's 3-phase, RCM1B if it's single phase. This was configured as an RCM1A. However, I did change out this motor contactor right here to a single phase contactor, and then changed out the motor inside this air pump to a single phase motor. So now it is effectively an RCM1B. And what these do is these are motor contactors. So these are actually what make the connection or connect the motors in the siren to electricity. And that is done through a magnetic relay. It's kind of hard to see, but these right here will slide in. Once they're energized, that completes the circuit and will start the motor. So again, you have three. This guy right here, this controls the chopper motor or the fan up there in the top. This right here is your blower motor. That's the air pump we were speaking of. And then you have your rotation motor down here. Power enters the unit through here. I actually don't have it hooked up to electricity right now. I have all the wiring stored in that box, so I can move this unit around. These two wires right here are actually going to another control box, which controls that third or auxiliary signal with those two valves up there. And we'll visit that here shortly. Obviously power comes in here. This right here is actually a special kind of time delay relay called an agistat, and I believe, if I'm not mistaken, it uses differential air pressure to create a time delay. So when you are running your siren in a wavering tone or the attack tone, what this does is it keeps your rotator motor and your air pump motor running throughout the signal as the siren cycles up and down, because you want the volume to stay consistent, and you still want this horn to be rotating around to be projecting that sound in a 360-degree pattern. So what this is a time delay. As the power is cut to it, it keeps these energized through the signal. Now here on the top is a adjustment knob. It starts at 0 or 1 and then all the way to up to 15. So you can turn this right here and adjust the length of the delay on it. I have it set on like 10.5 seconds. I actually haven't run this with the blower yet. I don't have appropriate wiring or appropriate gauged wire to do that yet. So I'm gonna have to play with that once I get everything that I need to run this siren properly. Down here, this is a big transformer, and Federal gave you the option with this siren to tap into different voltages for the chopper or fan motor. So the maximum pitch of the siren can be controlled with these 6 terminals right here, you had your common, and then in increments of, I believe, 20 volts, you could change where that siren would peak out at as far as pitch. And that was to combat ambient noise levels. If you had something that made a lot of ambient noise at a low pitch, you'd want the siren to peak out high, and vice versa. If you had a high-pitched ambient noise, maybe you'd want that siren to peak out a little bit lower just so you could hear it over that ambient noise. Now, over here you have switches to test and control the individual motor starter and components of the siren. The control switch allows you to test these various components without actually having the siren make noise, and that's so you can more or less silently test the siren or check electrical connections without having it alert the public if you're trying to be quiet. The chopper, obviously, that is the fan. These are all defaulted to automatic. There are 2 wires up here. These go to a control timer, and again, we'll visit that here shortly. And that wire will be shortened up. The whole wiring situation is temporary on this. And then you have 1 wire that comes in down here, which actually controls the different signals from the timer. And we'll get into that. But that is to test the fan. This is to test that blower we were talking about. And then the rotator can be set to automatic, which the controller will run that. You can set this one to off. None of these other 3 can be set to off. And that's if you don't want the horn to rotate for some reason. If you need to park it in one direction and leave it that way, you can have that, and then you can run it over to test. Now, again, I don't have this hooked up to power, so these switches right now aren't going to do anything. And I think that is about it. Yeah, so 3 motor starters, time delay relay, then you have a big transformer which controls the maximum pitch of the fan or the chopper at full speed. And obviously you have some fuse protection here, and then everything gets routed out of the box like that. So this would be the control cabinet for the Siren signal timing unit. Normally this would be configured with a radio on top, and then down here would be your actual signal timer. Now this up here is a clock, and Federal Signal actually marketed this style clock, which they rebranded as the Model 75. This is a clock by the original manufacturer of it, and these were originally produced to be timing clocks for school bell systems. And there's a ring around here which rotates with the time. There's a little switch right here, and there are little tabs, if you will, that you'd put where you'd want that bell system to make a signal. And every time that a tab would run over this contactor, it would push down, and that would activate the bell system or the signal for 10 seconds. So Federal took that and they made it as a way to do either like a noon signal or, you know, several signals throughout the day if you were using this at some kind of industrial application where you wanted to signal certain periods of the day, or like a stop-start workday kind of signal. Again, usually there'd be a radio right there. I've mounted that just because I think it looks cool. Eventually I'll have that hooked up. It won't be running any kind of signal in the garage, but I've always wanted one of these, and I think they're pretty cool. But the main part of this cabinet would be the timing module, which this is called an AF timer. There were 2 very popular ones made, the AR and AF timer. These were produced for many, many years, through the 50s up through the early 2000s. This is the newest version, if you will, of this mechanical timer called the AF timer. And AF would be air raid timer if it was the AR, but it's AF for air raid and fire. And that's because it has this fire signal right here, and that is unique to the Model 1003 because it is a 3-signal siren, and that is actually what runs the special signal where this can do, you know, a high-low or a pulse signal, and that's controlled through this box right here. We'll get to that next, but that's what the AF comes from. as far as the AF model of this. So this button right here, and this is a test button, you'd press this, and as long as you were holding your finger on that button, it would energize all the motors, the siren would spin up, rotate, the air compressor obviously would be running this whole time, and then when you let go, the fan or chopper motor would start to spin down. However, that time delay that we talked about in the last clip would keep this siren rotating and that air compressor going for several seconds, and then everything would de-energize. Now, alert, that was an official civil defense function, so that was a steady tone for 3 minutes. Most cases, communities today use that steady tone for weather emergencies like a tornado warning. Again, then you have a fire signal. That's if you were wanting to use this system or the auxiliary system, the auxiliary signal to call out your volunteer fire department. This would make that special high, low, or pulse signal. And then you'd have civil defense attack, and that is the undulating or up, down, wavering signal. Some communities use that for their tornado signal. Now that civil defense is no longer active in the United States, these don't really mean much. There's just basically steady and then like wavering tone. And then this button right here would cancel any active signal that you had. Now this is a mechanical siren and a mechanical timer. Everything on this siren was circuit board era. So everything is run via relays and motors and motor contactors. There's no, circuitry or any kind of logic board or anything in here. So what you have are 3 relays here on the top, and then you have a clock motor running these wooden cams with these little micro switches on the top here. And what happens is you press a button down here, and then this starts this little motor running for 3 minutes. And as these little switches are depressed, that is what actually energizes the motor or produces the siren signal. So, for your steady, you have one long steady note, which is just like one long bump on the outside or the circumference of this. And then for the attack signal, you'd have a grooved wheel. So it would intermittently, as it ran over that switch, turn on the siren, turn it back off again. That would run for 3 minutes. And then over here, you actually have the auxiliary or fire signal. And I believe this one actually only runs for 2 minutes. It looks like 2/3 of the wheel are cut out to where they'd be depressing that switch. Again, you can make that fire signal either an up-down with a high-low, or you can make it a steady. So that you did have that option, and by reconfiguring where these wheels are in relation to these little micro switches, you can change what each signal does. This is a transformer right here. This is a dual voltage unit. It will accept either 100 or 240 volts. And then you have a terminal strip down here and instructions on how you were to wire up your siren based on the voltage and what you wanted it to do. So I have the standard setup here. These 3 wires actually run into this 3rd signal box, but if you were running a 2-signal Thunderbolt, a 1000 or 1000T, you would be using 2 wires, and they would run back into that motor control box, and that would be what is controlling the motors turning off and on for your various signals. This is a 3-signal siren. It has 3 wires coming out. They feed into that box, and then that box has 1 wire, master wire, which goes into that motor control box, and that runs all of the signals. So that's what that looks like on the inside. If you were to have, let me get this shut here. If you were to have a radio here in the top, the fuse box is not original, and that little relay right here is not original, but that counter is original to the cabinet. And what that does is that is a kind of ground truth way to know if your siren is receiving signals. So this is a cancellation counter. So if you were to activate your system, you'd hit the cancel button after you're done testing it every time, or not a cancel button, but you'd hit the cancellation command that would go through the radio, and every time it picked up a cancellation, this thing would tick up 1. So you could go after a test and this is before the days where you would have computers that would tell you if your sirens went off or not. You could go visually verify that your signal actually sounded. So that is the control box. This is called an ARCH. There are different sub versions of this box, but the standard nomenclature we use is an ARCH, and that's the antenna right there on the top. It's a little bit difficult to see, but it's this guy right here that would go down into the radio. Again, I've taken the radio out. I actually have this bell timer in there, so if I wanted to run a noon signal, I could. Yeah, and so we'll go on to the final control box, which is the auxiliary fire signal. So the third and final control box on the Thunderbolt 1003 is the RCM3, or the auxiliary signal box. And what this does is, this entire thing is to run those two valves up there at the throat of the horn. Those two boxes, it looks kind of like a bow tie, and you have two pieces of conduit coming out. You can see there on the far side. Now, this group of terminals right here is your main power in, and then your main control line. This goes back to that RCM1 and plugs in, and that's actually what tells the motors to turn on and turn off. These three terminals, you have your solenoid number one, solenoid number one, solenoid number two, and then your common, and then you have those three inputs coming in that we saw in the AF timer that run through this panel back to the RCM1. Now, again, if this panel didn't exist, there would only be two wires, and those would go just immediately into the RCM1, but because we have a 3-signal siren, those are routed through this control box. You can see all the wires go through these channels here. They have little covers on them. Go down through here. This is a contactor relay, and this is what energizes the solenoids. Now, this part right here is a motor with little micro switches in it. It's a little eddy current motor. And so when that high-low signal is selected, there's a wheel back here that begins turning. And what that does, I don't know if you're gonna be able to see it, but there's a little rocker switch right there. And as it turns, it makes that little switch go up and down. And that's what alternates the high and low signals. You just saw it rock there, just like that. So you can adjust the speed of that. You can make it go high-low very quickly, or you can make it go very slowly. Standard, I believe, was set to fast. Most videos, if you search for Thunderbolt high-low on YouTube, they're gonna do the faster signal. So that is what controls the alternating high and low. Over here, you have another switch panel similar to on that RCM1. This switch right here, again, you have automatic and test. So automatic means that the timer is going to be running everything. Test is to manually check it. So the modulator, if you were to hit that, again, this is not connected to power. This will energize this little motor right here. That wheel begins spinning, and you can see that little rocker switch going up and down. Tone 1 would be solenoid number 1, or the high note. Tone 2 is the low note, and you can manually turn those on and off. And if you search on YouTube, you can find videos of people manipulating this. So this is what creates the high-low signal as far as the valves opening and closing. Now, whether that's steady or a rising and falling high-low signal, again, that's controlled via that AF timer and how you configure the little wooden cam wheels in there. So yes, this is the RCM3, and this is what makes the Thunderbolt 1003 unique. All right, so here's a detailed kind of look at what one of the inside of the solenoid compartments look like. There's one on each side, obviously. One covers the high note and one covers the low note. This is where was a very chattery solenoid, so I'm trying to clean it up a little bit. I think there's a little bit too much corrosion on the inside on this valve slide here, right there. And I think it was causing some arcing. I'm not really sure. So I've cleaned that up a little bit to see if I can quiet that a little bit. It chatters Anyway, you can see the slot right there, and here is the shutter valve. And what happens is when this is energized, it is pushed in and blocks off the airflow. And there's one on the top, and when it makes the high-low, they alternate in sequence. Like for a pulse, it would be at the same time. But that's kind of what the inside of that looks like. This guy right here connects onto there, and then that whole assembly fits in this compartment, and you can see where the anchor points are. There's a little bit of rust on this side. The other side looks fantastic. It's almost brand new, but at some point some water got into this one. All right, so hopefully this video was informative and kind of explained how this siren works and the features of the 1003 that make it unique. This is a pretty cool siren. In the future, I will be making videos of the components of it in operation as I get everything set up. If you have any questions, don't hesitate to leave me a comment. If there's anything you'd like to see, also leave me a comment. And yeah, thanks for watching.